thank Mainspring Energy for sponsoring today's webinar. Their sponsorship directly supports the ABC and our program. Thank you very much, Mainspring. Before we start with content, I want to do just a little bit of housekeeping. Right now, you should be able to hear me and see the slide titled Quick Notes. If you're hearing echoes or your sound quality is bad, you can change your audio options in the GoToWebinar toolbar, which is likely on the right side of your screen. And if you're still having any trouble throughout this webinar, please send the organizers a message. We'll be happy to help you. You can do that in the questions pod on the toolbar. And don't worry, we are recording this webinar. The recording and the slides will be sent to you as a registrant within a few business days, as well as being posted on the ABC website. And if you have any questions about content, we'll be handling all of those at the end in a Q&A session, but you can ask them throughout the webinar using that same questions pod. We encourage you to please ask your questions as soon as you have them. And with that, I'm going to hand things off to our moderator today, Sharon Rice with Mainspring. Sharon, you want to take it away?
Thank you, Caroline. Our speakers today are Matt Shumway, who's the Director of Business Development with Mainspring Energy. He leads partnership opportunities with companies and projects for renewable fuels and EV mobility applications. He joined Mainspring in 2022, and prior to that, he served for 9 years with Chevron working on renewable fuels in analysis, business development, and strategy positions. We're also joined today by Adam Wright, the CEO who co-founded Vespine Energy in 2022 to help address the growing problem of methane emissions by increasing utilizations of biogas through aggregated development of distributed electricity generation. He's a seasoned managing executive with around 20 years of experience building and growing companies across a variety of fields, including metal 3D printing, submarine engineering, and real estate. In 2013, he also founded Deep Flight, a marine technology manufacturer that became a global provider of personal and tourism submarines. Welcome to today's webinar.
All right, great. Well, so thanks, Sharon. So hello, everyone. I'm Matt Shumway with Mainspring, as was already mentioned. We're really excited to be chatting with you all today about the opportunity to look at electricity projects in the biogas and landfill gas space, a topic that we're sure most of our attendees are very familiar with. We wanted to kick off the discussion today with a poll, and so that's either going to be popping up right now or as soon as we advance the slide. Yeah, great. And so we put this together just in an attempt to try to solicit some feedback from the audience on biggest pain points in biogas or landfill gas to electricity projects. And obviously this is not an exhaustive list, so if your favorite pain point is not listed, choose the next best thing, but we have difficulty obtaining air permitting, need access to more land, economics don't pencil, don't have the capital budget, or you don't have a gas collection system. So we encourage you to participate in this poll this time so that we can get some idea as to some of the headwinds that might be facing a project in your space. So I'll give a minute for that to happen, and Sharon, as soon as you see a consensus on some answers, if you want to share the results, that'd be great.
Yeah, I'm happy to. Why don't we give it another 5 or 6 seconds or so, and then we'll see what the audience is bringing to the table.
Great.
All right, let's go ahead and wrap the poll, Caroline. I'm curious to see what's top of mind for our audience today.
Are you able to see those results, Sharon, or you want me to share them?
Why don't you share them?
All right, so we have 13% saying difficulty attaining air permitting, 3% saying need access to more land, 60% saying economics don't pencil, 13% don't have a capital budget, and 11% don't have a gas collection system.
Okay, that is not super surprising, but also extremely helpful. So we're going to be talking today through, we're going to first hit some tailwinds that we think are helping this space out, But as Adam and I chat today, we'll make sure that we address some of the topics that were hit here. So if we could advance the slide. So we talked a little bit about those headwinds there, like I said, that we'll incorporate into our discussion. But the reason that Adam and I are here and that our companies have been working together closely over the last couple of years now is really because of these tailwinds that are impacting the biogas and electricity markets. So this group right here is going to be very familiar with both topics. The first column there is methane emissions from landfills, and this could be representative of what we see in wastewater or in the agricultural waste sector as well. There was a report that came out this spring on CNN about the amount of emissions that were coming from landfills, and got a lot of publicity, and people were talking about this a lot. And one of the comments one of the data points from it said that it was estimated around 20% of globally human-caused methane emissions come from landfills. So we already know in the biogas space that this is a hot topic and something that we are uniquely qualified to address and help use this wasted gas that can be very harmful to the environment and turn it into something good. When we look at the other side of this slide, we also see the opportunity related to the growing demand for electricity, and that the 5-year load growth forecast by grid planners has nearly doubled. And you can see that second bullet point, up from about 2.6% nationwide electricity demand, 2.6 to 4.7% increases over the next 5 years. And that is largely driven by the use of data centers. AI is really impacting the growth there, which Adam can speak more about. Electrification in our industrial manufacturing processes, EVs, and other uses of electricity. So obviously, when we talk with customers or developers that are in the biogas space, RNG is top of mind. There are significant incentives, especially in the transportation market, to help provide revenue to that space, and we're not blind to that. Mainspring is very active in helping customers in the RNG space, and we promote it. We power upgraders. We want to make sure that we're a solution there. But this webinar is specifically focused on what is happening in the electricity space and how that could be a growing trend that wastewater facilities, landfills can participate in. So with that, I'm going to be turning it over to Adam. Adam, with Vespine Energy, are bringing a innovative business model to the table, which is creating a lot of interest. They also are taking advantage of innovative technologies. Mainspring being one of them, that he'll turn the time back over to me, and I'll talk about Mainspring, and then we'll wrap up with an exciting project we're working on together. So Adam, over to you.
Yeah, thanks, Matt. And yeah, we can go ahead and thank you. So, just a quick background on Vespine Energy. We are an energy developer focused specifically on distributed electricity generation fueled by biogas. So, obviously, and Matt mentioned that the gold standard in the industry today is RNG. However, we believe that the future of biogas is electric, and that's for a couple of reasons. Our approach, we have a technology and market-enabled approach that allows us to profitably develop sites of biogas production that are either too small or too difficult to develop for RNG. So, from a high-level perspective, and for many of you may be already familiar with electricity generation on biogas sites, but it's basically a 3-step process. Us as a developer, we install the infrastructure to extract biogas from a site. Many landfills already have gas collection systems, and we can integrate and interface directly with those systems. In cases where they don't have gas collection systems, we can provide the capital necessary to install that infrastructure. Once we have access to that biogas, we then put that gas into conditioning. So we filter raw biogas to remove contaminants and moisture, and compress it slightly so that it can be reacted in an LGen, which is step 3. So step 3 is power generation. processed biogas is then reacted in an array of mainspring allogens, which produces clean electricity. And once we have that clean electricity, we basically do one of two things. We have what we call an aggregated offtake, and we have what we call modular data center deployment. And we'll talk about those in more detail on the next few slides. So if we can advance to the next slide. So, the first approach at Vespene is what we consider a market-enabled approach. In this approach, we basically aggregate together multiple small biogas to electricity projects into large regional clusters and sell the resulting electricity and environmental attributes. So, there's been a recent shift in market sentiment or in energy markets that places a high level of importance and therefore a high value on what's considered a 24/7 baseload renewable. And when I say 24/7, that just means that electricity is available 24/7, 24 hours a day, 7 days a week, 365, of which biogas to electricity, particularly when generated using mainspring technology, is a prime example of. And there's only a handful of technologies today that are deployable that can reach this type of 24/7 renewability. Geothermal being one of them, nuclear being another, but biogas is uniquely able to be rapidly deployed and deployed in regions where that energy is needed. There's biogas kind of all over the place. Every state has landfills, dairy farms, wastewater treatment plants. And this generation profile is uniquely able to help companies and utilities meet their goals for 24/7 baseload energy. Our flagship project, which we'll talk about in sort of later in the webinar, has additional support through the Department of Energy Loan Programs Office. So this is our aggregated offtake approach. Again, we take multiple smaller sites between, let's say, 1 and 3 megawatts, aggregate them together in the same grid region, and sell the resulting electricity as part of a larger sort of virtual power plant. So instead of having one 3 megawatt power plant, we have multiple of them, and now we can have a 20 or 30 megawatt power plant in that specific grid region. So let's go to the next slide. So the next approach that we take at Vespene Energy is what we call technology enabled. So we are taking advantage of recent developments in the modularization and distribution of data centers. And what we do here is we essentially co-locate the physical data center onto the site of energy production, which then serves as a behind the meter revenue source to support biogas electricity development. And this can act as a bridge to other use cases. Potentially there's a delay happening in an interconnection, or there's some other electrical use case down the line. A modular data center can provide a bridge to that ultimate solution, or it can be a permanent installation. You saw on the previous slide, or one of the previous slides, that there's significant tailwinds related to deployment of data centers, particularly AI and high performance computing. And this is a method where we can, instead of trying to get the energy to the data center, we actually bring the data center to the energy. It sort of flips that conversation on its head. And in many cases, it can be easier to do that because it's a lot easier to send data in many cases, whether it be satellite or microwave internet, compared to actually trying to send electrons away from the site. And just so you can get a sense of scale, the data center that we have deployed here at a site in Wisconsin, a landfill site, that's a 2 megawatt data center load, and you can see kind of the size in relation to the truck in the bottom left corner, that it is relatively small and occupies a fairly small cross section of land. So this is what we call our technology-enabled approach, and this can also provide a solution for sites that do have large on-site use cases or on-site loads, but are producing more energy than is needed to support the on-site loads. And so the data center can then also act as an additional load or a sponge to kind of soak up any unused electricity that's produced at the site. So let's go to the next slide and just see, why have we developed this business model? We see a large opportunity in the biogas space, particularly in the landfill space, to aggregate together multiple smaller sites. So, in the American Biogas Council has been very helpful. They have a lot of data available about the amount of biogas that's out there that's either developed or undeveloped. But if you take a closer look at that and you sort of aggregate it together and you look at it through the lens of size, you can see that on a volumetric basis, there's a lot more undeveloped biogas left in medium and small sites than there are locked into large sites. And when we say medium and small, from a landfill's perspective, a small site is what we would consider a small site would be anything under 800 standard cubic feet per minute of landfill gas flow. A medium site would be somewhere between 800 and 1500 SCFM, and a large site would be 1500 or above. And so, if you, as a developer, we view biogas as a valuable asset. And if we believe that to be the case, then when you look at where that asset is aggregated, you can see that it is heavily concentrated in these medium and small sites. Therefore, we need to make a business model that allows us to profitably extract and generate energy from that resource. So with that, I'm going to turn it back over to Matt to talk a little bit more about the mainspring technology and how the LGen is sort of the best-in-class technology for this type of aggregated energy deployment. And then I'll take the mic back towards the end of the conversation to talk more about kind of our flagship project. So Matt, go ahead and take it away.
Okay, thank you. Yeah, so we can advance the slide. And I hope folks here are excited, or as excited as I am, kind of looking at what Adam and his team are bringing to market. Just when we see the numbers related to small to medium-sized landfills, and it's the same thing in wastewater and dairies and swine farms, food waste, poultry, really, and we are at the American Biogas Council, the Biogas Americas conference in Savannah a couple weeks ago, where a hot topic is how do you address these smaller sites. Really, you need to look at innovative business models, innovative technology, modularity, all the things that Vespian's trying to do, and we're excited to partner with them as their power generation technology. So the mainspring linear generator, or LGen, as you heard Adam call it, is what we have been working on at Mainspring since the company was founded in 2010. So we're a US-based, California-based company that's been working on a new category in power generation. There's a lot of bullet points on this slide, and just to kind of hit the highlights, it's a 250 kW power system. It's scalable, so you can have a single unit, or you can scale that up to meet any power demand with the power density of 25 megawatts per acre. It's a fuel agnostic process, which means that we can run on any gaseous fuel. That's really important when we're talking about different types of biogas, and when we're looking at the different components of biogas, we don't have any oxygen, nitrogen, or CO2 limitations. So you can run any N2O2 levels in that biogas stream that's coming into our system. We can obviously run on natural gas, propane, and then zero carbon fuels like hydrogen and ammonia. Minimal cleanup required. Obviously, we don't need to go to the same level as RNG. We can run on as low as 35% methane content in the gas. You can run grid parallel, meaning that it can sit behind the meter and just offset load, or it can be fully islanded and operate as a grid forming technology if you don't have the grid available. Near zero NOx emissions, which we'll talk more about, and it's a UL listed product, meaning that we can get this installed without, it's UL 2200 listed, and we use grid tie inverters that are UL listed as well. Talking about services, we also can provide O&M financing either through partners like NextEra that have a financial arm that they can provide to Mainspring, or if we're working with a developer, then you can work with a company like Vespine that's going to bring their own capital and their own ability to finance a project. And then we also have partners that we can work on the EPC and biogas cleanup side. So that's a quick snapshot of what we sell. If we can go to the next slide. So what is Mainspring helping to solve for? Well, when we talk about, we had that poll at the beginning, economics were the number one concern by far. And so really monetization is going to be a key aspect of any project that Mainspring is a part of. And this is going to be derived from a few things that we can bring to the table: higher efficiency, lower operating cost, dispatchability, modularity, right? So you don't need to strand capital, you don't need to waste capital on excess space. You can kind of size and fit what you need it to be. But that's always going to be a key pillar of what we're helping customers solve. Typically, though, a project is going to be most appealing when we can stack value propositions. So monetization with reliability, if we're going to need to power a wastewater facility, for example, and provide resilience there. Or emissions, if there's a biogas project that needs to be done, but it's in a jurisdiction like California that's going to have ultra low NOx requirements, Mainspring can be a really great technology fit there because we can meet those requirements. Or if you need to quickly get power to a facility, maybe you have an RNG project that's stranded, can't get electricity in time to meet your operations date, then Mainspring could be deployed to get you the power that you need more quickly. So these are all the problems that we are trying to solve in our space. So if you go to the next slide, please. So I wanted to share just at a very high level how the Mainspring technology works. And I know that this is a little more salesy, but hopefully it's also interesting from a technology perspective, because really what you want to do in these biogas to electricity projects is you need to think about things a little differently, and how can we extract value in areas that we haven't been able to in the past. So a Mainspring linear generator is a categorically new power generation technology. It's not an engine, it's not a fuel cell. What we do is, through the use of software, we compress fuel and air together. And the animation that you see on the screen is a depiction of what's happening inside of our linear generator. We have two oscillators that are just big, long steel tubes wrapped in magnets moving across copper coils that are coming together in a center reaction zone to compress fuel and air together. As you compress the fuel, the molecules bounce back and forth, temperature increases, and at a certain point, you're going to have an auto-ignition event where the atomic bonds within the molecule are going to kind of break down, and it's going to create a thrust or energy that's going to push the oscillators back the other direction. As they move back, they are sitting on a cushion of air, which is called an air bearing. That's going to just allow these oscillators to glide back and forth without any friction, creating electricity as they move backwards towards an air spring, which is ambient air that just captures the oscillator and rebounds or throws back the oscillator the other direction, creating more electricity as it moves the other way. So it's a pretty simple cycle to understand, The secret sauce to this whole thing is the software that Mainspring has developed to control the reaction event. And because we can control the reaction event, there's a number of things that we're able to achieve. High efficiency, meaning that we can get a full extraction of the fuel and conversion into electricity, all in a linear motion. Fuel flexibility, so we can run on any gaseous fuel and the system on the fly can adjust seamlessly between the different types of fuels that are introduced. That's software enabled. Ultra low emissions, even though there is an increase in temperature when we have a reaction event, it is below the level of NOx formation. So we have almost no NOx that's coming out of the system. And then you'll notice that's markedly absent in this system. We don't have any oil or greases. We don't have any spark plugs. We don't have any rotating equipment. So a lot of the standard things that need to be replaced and maintained in an engine don't even exist in a linear generator. We do have to keep the system healthy. We have seals and filters to move a lot of air through the system and seals that interact with the fuel and air. So we replace those on a routine basis, but we have to touch the engine a lot less, which means that our maintenance costs are lower and our uptime is higher. So all of these things help to deliver economic value. And I think about the story from the British cycling team that focused on marginal improvements in their team's performance, right? Not blowing up the whole model and figuring out how do we do everything all better, but how do we marginally make improvements in our team and in our performance and in our bikes and in our diet and sleeping and everything that they did. Those marginal improvements and marginal gains ended up turning into a record champion team. It's the same way with the biogas to electricity projects. How can you find incremental improvements that are going to help you extract more value and get a project to economically pencil? Getting something with higher efficiency, like a linear generator, working with a Vespine Energy that's going to use a business model that can have a modular data center as a bridge till you can get to the aggregated offtake. There's a lot of different things that incrementally can add up to make a very lucrative project. So I'll advance to the next slide, please. This is just a quick high-level snapshot of how a linear generator compares to other existing technologies. A linear generator is not a silver bullet. That's not what we're here to say. But in the biogas space, we do feel like this is a really great technology that can help provide marginal incremental returns to your project that can help get it over the line. And next slide, please. So I'm going to turn it back over to Adam to talk about a project that we're excited to partner with Vespine on that he alluded to earlier. That really is, I believe, a culmination of a lot of the things that we've talked about today. So Adam, back over to you.
Yeah, thanks, Matt. So, when we take a technology like Mainspring, a Mainspring linear generator, and we combine it with a business model like we've developed at Vespine, what do we end up with? And we end up with what we call Project Pleiades. Project Pleiades. Pleiades is a reference to a star cluster that is composed of many different stars. We have taken that same naming approach and applied it to an aggregated landfill project. So we are very excited to say that we've been approved for part one of a very large loan application with the U.S. Department of Energy. U.S. Department of Energy has a program called Title 17, which provides very low cost financing for what they consider innovative energy projects. And by combining an innovative technology like Mainspring with an innovative business model, we end up with a very successful application with the Department of Energy. So this loan program would provide up to 60% of the capital required for an aggregated landfill project across 50+ landfills in 21 states. It would be the commitment from the US government would be for the lifetime of the 20-year project. And by having access to that low cost of capital, we're able to deploy these technologies and scale them out very rapidly and develop sites that would be previously undevelopable because of economic barriers. So let's go to the next slide just for a quick map. So Project Pleiades is we are utilizing distributed baseload renewable energy with community-based landfill biogas. And so we're very specifically targeting landfills in the, say, 1 to 3 megawatt range. So this is going to be landfills in that kind of smaller size range, sort of 900 CFM and below. And the aggregated energy will be sold to a corporate or utility off-taker depending on the grid region. And once again, this sort of this goes back to the recent changes and in sort of perception of energy markets that places a high level of importance and value on this concept of 24/7 baseload renewable energy. So in aggregate, this project will produce over 80 megawatts of baseload renewable energy and reduce annual emissions by over 1 million metric tons of CO2e annually. And that's because a lot of the sites that we're targeting have no existing gas collection system. They're underneath the EPA mandated threshold for installing collection systems, but they are still capable of producing substantial amounts of electricity. Just a quick caveat on this map. This is a theoretical map of potential targets for the project. Not all of these sites have been signed up to participate. We do have 15 sites so far that have signed up to participate in the project across several different states. A lot of the information is publicly available online, but we'd be happy to answer any questions about that. But we're really excited about Project Pleiades. We think that this really showcases the ability for mainspring technology to provide a modular solution for electricity generation with very low operating costs, and allows this type of business model to come to fruition. So I'll pass the mic back for, I guess, to you, Matt, for some ending comments.
Yeah, thanks, Adam. Yeah, we're equally excited to work with Vespene on this. It's not only an exciting business opportunity, especially for these smaller biogas and landfills, but it's just a good thing to do, and that's kind of what we're excited about as a mission-driven company like Vespene and like many others in the space. We want to do good for the environment, and so this is a great way for us to kind of provide some visibility into how a business model could come together. So I think we'll go ahead and jump now to questions and answers, and I don't think Adam and I can see the questions, so we'll turn it to Sharon, I think, to throw some questions at us. Sharon?
Absolutely. We've had quite a few come in. How does Mainspring achieve near zero nitrogen emissions?
Okay, great. And I guess Adam and I will figure out who's the right person on the questions, but that one's definitely me. So yeah, the short answer is we are using the software, the power electronics in our system to control for a lot of different aspects and metrics as we are reacting the fuel in our linear generator. A key component is temperature. We know that at a certain temperature, there is going to be NOx formation. And when you look at like a diesel engine, for example, they're going to have a very similar compression of air. But then when the fuel is injected in that system, the temperature gets so hot near the fuel injector that's what leads to the nitrogen atoms combining with the oxygen atoms to create NOx in that flame front, as it's called. So because we don't have a flame front or a hot spot, the the temperature stays cool and allows us to operate at a level where there's very, very little NOx. And just as a data point reference, we have units that are permitted and for continuous use operations, and they're operating continuously in South Coast, California, AQMD, where it's a less than 2.5 ppm NOx level. So we have them in South Coast and Bay Area, San Joaquin Valley, in New Jersey, in Florida, and Colorado, all meeting NOx requirements in those states.
Okay, great. The second question is, how do you make the economic case for existing LFG collection systems, but the gas generation is into the declining part of the LF's lifespan?
Sorry, can you repeat that question?
Yeah, that's yours.
I'll run it again. How do you make the economic case for existing LFG collection systems, but the gas generation is into the declining part of the LF's lifespan?
Okay, so I guess the question is related to kind of potentially closed landfills as opposed to open landfills that have, stopped taking in organics. Yeah, I mean, I think we do look at closed landfills on a case-by-case basis. Even when a landfill closes, there's still going to be a significant amount of gas that's going to be left in that site. And depending on the state, that landfill is going to be regulated to be capturing and destroying that gas for decades to come. And so really the economic case is basically one of sort of modeling. So you need to, if we're doing a 15 to 20 year offtake for electricity, we just need to size the plant based on 15 to 20 years of gas flow. So that's probably going to be downrated from what the landfill is producing kind of on day one, so that over a period of time that the economics work. So it's really a site by site question, and is dependent on kind of what the actual gas flows are.
Okay, great. The next question is, can the generation device operate on 200 BTU SCF tail gas?
Okay. So I think there's a yes and no aspect to this. Technically, we know that the unit could operate at that level. However, there are some limitations related to our UL listing and rating that require us to have a bit higher BTU content. So like I said, we can run down to about 35% methane concentration, which would be roughly in the 300 to 350 BTU per scuff range that was referenced. So we are looking at some applicability or some applications where we can take that lower BTU content tail gas and just blend it up to that 300 to 350 range with natural gas. And that way we can take what is today a waste product, that's already coming from a waste, and turn that into something useful, into electricity. So we have a couple of applications that we are currently in the design and exploration phase with some customers on.
And Matt, I could comment on that too, because we've also looked at that business model kind of in partnership with RNG companies. And one of the things that, instead of spiking, like what Matt was mentioning, spiking the gas with natural gas to create a mixture that's 300 to 350 BTU per cubic foot, that you could feasibly also siphon off some of the RNG to go and mix with the tail gas to create that electricity. And what that enables is kind of a much lower, if you're able to self-produce your own electricity and not bring electricity in to power your systems, you can sort of significantly lower the CI score of your site. And if you lower the CI score of the site, you can qualify for things like the clean fuels production tax credit. I think that's 45Z. So we've looked at a couple of business models there where you can actually achieve significantly lower CI scores by doing that trick.
Yeah, good point.
All right. We have several more. Here's another question for you guys. Great talk, Adam and Matt. No burning in the linear generator, waste material coming out of the reaction zone. What form does the waste output take and where does it go?
Okay. Yeah, so there's no burning. It's just a compression ignition process. So we, like I said, we don't have any spark ignition, no flame front. It is a reaction process, right? So if you're, there are going to be, there's an exhaust, and it's a lot of air that we are moving through our system. So a lot of air that's in the reaction chamber, and so mostly air that's also coming through the exhaust. If you're putting in a carbon-based, fuel like methane, like a biogas, then you are going to see CO2 coming out of that. But then, like I said, we have ultra low levels of NOx and CO, particulate matter, all that, all below permitting thresholds. So, and maybe one other comment I just make about CO2 is while we do have the CO2 coming out, if it is a carbon-based fuel, because our higher efficiency, because we have a higher efficiency, it means that we have a lower carbon footprint on a per unit basis, meaning that you have more electrons that you can spread that carbon dioxide out over, which does provide a benefit. Then, of course, if we are running on a zero carbon fuel, then there's no carbon coming out at all.
I can comment on that a little bit, just from a life cycle emissions standpoint. If we're installing gas collection system that wasn't there before, and you're pulling that methane, so instead of releasing the methane directly into the atmosphere, you're essentially converting that methane into CO2. You've sort of gained a 28x improvement on emissions, because methane is 28 times worse from a 100-year perspective. So that's kind of a very cut and dry sort of win, let's say, for the environment. There is also a substantial win if you take an existing flare and convert that into electricity derived from mainspring, because there is no flare technology that is going to be as efficient from both a CO2 or a methane destruction perspective as well as a NOx production perspective. So if you draw a box around what we call the baseline, so if the baseline is sending landfill gas into a flare and flaring it off to you're going to be producing, let's say, X amount of carbon. If we are, and there's going to be a sort of X amount of methane that's also emitted because it's not combusted fully. If we then take that same system and feed it into a mainspring or an array of mainsprings, then in all cases, your efficiency, obviously, firstly, you're generating electricity where you weren't before, but also your destruction efficiency of that methane is going to be increased, and so therefore you're sort of making a marked improvement in terms of atmospheric carbon emissions by converting flares into energy production with mainspring.
That's great. Adam, I have a couple of questions for you, and then maybe Matt can chime in as well. Do you have a comment about the economics of electricity generation versus transportation for RNG, given the LCFS emission credits in California? This is very attractive for dairies.
Yeah, so that is a topic for conversation. I think obviously our presentation today was focused much more on landfills and landfill gas, whether it be electricity or RNG upgrading is, essentially exempt from generating LCFS credits. So really the LCFS conversation is really focusing on things like dairy farms. So, in this, and that's one of the things that has, sort of that spawned, let's say, the gold rush for RNG, is because of higher LCFS pricing, in the past. And then the ability to stack LCFS plus RIN credits just makes, dairy RNG a very valuable commodity. However, now that we're in sort of a regime of very low LCFS pricing, and a lot of the larger dairies have sort of already been developed into RNG, it makes solutions like Mainspring that can derive like a very, very low CI score. So any electricity project, just by definition, is going to be deriving a much lower CI score because of the various there's no energy that is input and energy input needed to the system like there would be for RNG. So projects that are based on electricity can derive very, very low CI scores and therefore still maintain high levels of profitability with depressed LCFS pricing. So I guess that in summary, yes, this is an electricity and distributed generation approach is a very valid business model for dairy farms.
Yeah, maybe Sharon, I could just a little bit of color on that. Yeah, I totally agree with Adam, and I'll just share when I started working on biogas to electricity projects at the beginning of 2022, I came from working in the RNG space where we were trying to reach -250, -300 CI score on dairy biogas to RNG. And then I was given a model here that said, that they were trying to achieve, or they were modeling -500 CI. And I thought that the team was crazy at first, but as I dug into it and I saw existing pathways and we worked with consultants, realized, wow, these CI scores can be very attractive on an electricity project. And I'm sure most folks saw that there was a pathway, that was approved a few months ago that was well past -700. And so I do think that it does create a great opportunity. We know that CARB's going through some changes in rulemaking right now, and the ABC is very involved, and Mainspring's very involved in making sure that we're advocating for things that make sense. But it also looks like electricity projects do have a reason to be optimistic on what CI scores could be, and how that could create some greater revenue generation for these projects.
Great. I have one more question for Adam, and then it looks like we'll be out of time, but we can follow up with the rest of the audience individually. The last question is, can you comment on the economics of interconnecting distributed power to the grid versus interconnecting RNG directly into natural gas pipelines?
Yeah, I mean, look, we are not an RNG developer, so I can't comment necessarily on the cost related to that, but what I can comment on is sort of anecdotal that trying to get a site hooked up to a pipeline and actually transporting molecules is harder than transporting electrons, especially when we look at the sort of the smaller size range. So when you start looking at the small, and that's one of the reasons that RNG has difficulty penciling out for these smaller opportunities, is because the costs related to interconnecting a pipeline and sort of digging a pipeline to the site, it doesn't really scale down with size. But from electricity perspective, it is in many cases easier and cheaper to interconnect, say, a 1 megawatt electricity generation facility than, say, a 7 or 8 megawatt electricity generation facility, just because there's less upgrading that needs to happen on the grid. And so although there are sites that we need to ignore or sort of pass over because of high interconnect costs, because of the focus on this smaller size range, that's actually to our advantage because it speeds up the interconnection process in general and makes it sort of substantially cheaper than for sort of larger utility scale. So yes, I mean, I think the interconnect cost is one of the reasons why an electricity approach is a sort of a better approach overall from an economic standpoint for these smaller sites.
Yeah, I again totally echo Adam's comments there, and I'll just say, yeah, we it's always going to be project specific. And I think as I've been working with developers over the last couple of years, a lot of them will go into a project and it's, let's get the gas rights first, and we're going to evaluate all options, electricity and RNG, and all the different revenue streams that could be associated with either pathway. And then they might learn the pipeline is way too far away, and so we need to try to figure out if we can make electricity work. Or happy days, the pipeline is close, and this one is just big enough that we can make RNG work. So I think it really becomes very site specific, and so it's a good idea to keep all options open at this point. And we've seen projects that have swung back and forth. Initially looked at a power and project when we all thought e-RINs might be a thing a couple of years ago, and now and then swinging to RNG, and then figuring out that D4 RINs are terrible. And so now looking back at power again to see, can we make some of these alternative business models like Adams pencil here? So yeah, we definitely encourage discussions with both Adam and myself on any of these. If you are a landfill or wastewater facility, let's talk and see if we can help you out and figure out if there's a good economic justification for your project.
All right, thank you for that. It looks like we are out of time today. We'll be following up with anyone on an individual basis if we weren't able to get to your question today. Again, thank you for joining us, and we will be sending a copy of the recording as well as the slides out in the next few business days. Thank you all. This isn't goodbye. It's till next time. We appreciate your time today.
I just wanted to add, there will be a survey at the close of this webinar. Please fill out that survey. It really helps us improve our future webinars and gives a little bit of information back to Mainspring. Thanks everyone for joining us. Have a great rest of your day.